Hi class, let's take a look at example 3. And one aspect of these equations, these coordinate points that you're going to notice is that the larger the circles, the harder it is for the scale. So all I need is a basic scale. In this case, remember that, well, all of these are r theta. So technically, this coordinate point is on a radius of 5. So I'm just going to hit 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is technically 5. That's negative 5. And, well, I'm just going to put a portion of the circle, definitely not to scale. And then the coordinate point is at 3 pi over 4. So technically at about here. So that's your coordinate point. This represents, in terms of r comma theta, the actual value of 5 comma 3 pi over 4. As we express it in rectangular, we're going to have that x is equal to r cosine of theta, y is equal to r sine of theta. And for both of these, we're going to get 5 cosine of 3 pi over 4 and 5 sine of 3 pi over 4. And please evaluate these two, and we'll obtain decimal approximations. So the actual cosine of pi over 4, it's going to be, well, a negative square root of 2 over 2. So this one will give us a 5 times negative square root of 2 over 2. And this is 5 times, well, square root of 2 over 2, which as decimal approximations, we're going to get that this is negative 3.54 and 3.54. So in terms of our final solution, basically r comma theta of 5 comma 3 pi over 4, this can be expressed as rectangular, and this happens to be negative 5 square root of 2 over 2 comma 5 square root of 2 over 2, which happens to be negative 3.54 and 3.54. Hold on, let me fix that last one. Okay, so that's our final solution for this particular coordinate point. Most of these are really simple. If you were to get some weird angle, you would change it then from radians to degrees and then go from there. But the vast majority of the equations that we're going to do later are going to have a domain from 0 to pi or 0 to 2 pi.